Find the equivalent future value at the end of the third year, F3. In this problem, we are provided a cash flow diagram. In the diagram, there are negative cash flows at the end of the first 5 years, in addition to one single positive cash flow at the end of the 8th year, which is equal to $2,000. The annual interest rate equals 3.75%. The question asks to find F3, which is the equivalent future value at the end of the third year. The dotted arrow represents an equivalent amount, which is the equivalent cash flow at the end of the third year if this one value were to replace all the other cash flows in the diagram. We'll begin this problem by creating an equivalent cash flow diagram. Doing so will make it easier to compute the negative cash flows by equating these 5 negative cash flows to the sum of a positive gradient series cash flow minus a negative uniform series cash flow, where their sum would equate to the original cash flow diagram for these 5 years. To solve for the equivalent single cash flow at the end of year 3, we'll first compute an equivalent present value for all cash flows, then we'll convert the present value cash flow to the future cash flow at the end of year 3. To make this latter conversion, we'll multiply the equivalent present value, P, by the appropriate discount factor, based on the rate, I, and the number of years, or compounding periods, N. The rate, I, equals 3.75%, and the number of years, N, equals 3, because we're converting an equivalent present value to an equivalent future value 3 years in the future. Since the rate, I, is slightly positive, we would expect this discount factor will be slightly greater than 1, because it equals 1 plus I raised to the n power. After plugging in the decimal value for I and 3 for n, this discount factor equals 1.1168. Next, we need to calculate the equivalent present value, P. This equivalent present value will include 3 terms: a term to account for the negative uniform series cash flow, a second term to account for the positive gradient series cash flow, and a third term to account for the single positive cash flow at the end of year 8. So now, it's our task to compute 3 more discount factors in order to calculate P. For all 3 discount factors, the rate, I, will remain at 3.75%. The value of n will be 5 for the first 2 terms, and n will equal 8 for the final term. We'll first compute the uniform series present worth discount factor, and after plugging in the values of I and n, this discount factor equals 4.4833. The uniform gradient present worth discount factor is a little more involved, but can still be calculated by plugging in the variables I and n, and we get 8.6368. The single payment present worth discount factor equals 1 plus I, all raised to the negative n. After plugging in the appropriate values for n and I, this discount factor equals 0.7449. At this point, we can compute the equivalent present value of the cash flow diagram, which equals $111.83. Lastly, we have to convert this present worth to a future worth after 3 years, which equals $124.89. When reviewing the possible solutions, the answer is B.